Hello everyone. So today we will talk about the planar kinetics of a rigid body. So before the video starts, I will let you guys know about the conditions we use. So the first condition will be a car moving up a slope which is 30 degree, and we're gonna calculate its acceleration, which is ag, normal force and height. For the second condition, it will be slightly different. So we will calculate the normal force, ag, which is acceleration, and we're gonna prove whether the car is slipping or not. So now I will let Lim Ji-wei to explain the calculation of the first condition.
Hello guys, so now I will explain about the condition 1, which is there's a car on a slope. There's 30 degree from the ground level. So basically when we meet this type of question, so we will going to draw out the free body diagram of the car, so that we can know that we can account all the forces that acting on the car. So now you can see on the free body diagram, there is a slope here, and the slope is 30 degree up on the ground, and actually this 30 degree is actually same with the angle between the W and also the N. If we elongate this force, and this angle will be 30 degree. So W is the weight of the car which is acting perpendicularly down to the ground, and there is a normal force. Normal force is actually same with the weight of the car, but we need to adjust it to act at the same axis, which is the y-axis in this case. And then as you guys can see, this is the small f, which is the force that cause the car to move forward and caused by the weight of the car. If we adjust this force into the x-axis, then there is a force that acting on the car, then cause it to move forward. And there is a big F. Big F is actually the frictional force which is act backward. And as we know, there is a formula about the frictional force, which is F equal to mu n, which is the coefficient times with the normal of the car. And here is the F is 3 meters from the ground, and the N with the point B, the distance is 2.5 meter. So now we're going to start to solve the problem. When we meet this problem, we will start to solve it from 3 ways, because as you guys can see, this is x-axis, this is y-axis. So we'll solve it from x-axis, y-axis, and also the moment that causes it to rotate at the point B here. So first we'll start at x-axis. X-axis, there's 3 forces that act on the x-axis. The first one is the small f, the second one is the W. Not clearly you can see the W is acting on the x-axis, but actually in this case, the x-axis is together perpendicular with the car, and the y-axis, the x-axis is parallel to the car, and the y-axis is perpendicular to the car. So actually this W, and it have a x-axis force and also y-axis force. So the x-axis force of the W also cause the car to move forward. So here we can get this formula, because the W and the small f are acting at the same way, and the big F act in another way. So we can take the force to minus. You use the weight times the gravitational force, and then we shift it to the x-axis, and then we minus with the bigger F. Okay, there's a bigger F. The coefficient is 0.24. We times the normal, and we can get the equation. The second one is, because the car is not flying, right? So there is a normal force and also the force that acting downward, which is the weight of the car by acting it to the y-axis. So N is actually equal to the force downward. So the lastly is the moment at the B. Moment at the B, there is actually three forces that acting. on the car. The first one is the bigger F, second one is the normal, and last one is the small F. And this one, 115, 1,500 force are actually we go near F equal to ma, right? So this is m and this is a. So we times the distance, we get the moment. So we're doing substitution simultaneously, and then we can get the answer. Then we can get the acceleration of the car. So finally, then we can take the kinetic energy is equal to the gravitational potential energy. So cancel out the m, and then we get the height of the car on the slope, which is this h. Okay, thank you.
Okay, so now I will talk about the calculation for condition 2. So before we do the calculation, we must assume something first for this condition. So here is the assumption: the mass of the car and the person is 1,500 kilogram, and then for the mu it is 0.24, and then for the driving force, which is F, is 12,000. Okay, and then for the formula of the friction, it must be mu n, small f equal to mu n. Okay, so now let's go to draw the free body diagram for this condition. So this is the free body diagram for the condition 2. So we got a big F here, which is a driving force, and we got a normal force, we got weight, and we got frictional force. You guys might be feeling weird why this direction of the frictional force is to the left. It's going to the left but not to the right. So let me explain about this first. So as we all know, this car is moving to the left, right? It's moving forward. Okay, so definitely the wheel will move in anti-clockwise. That's why the frictional force must oppose the force of the wheel, and that's why the frictional force is in left, its direction is left, not right. Okay, so now let's start with the calculation first. We start with x first, the summation fx first. So we can straight away sub the number. Okay, give me a minute. 12,000 equal mass agx. Okay, oh yeah, forgot about it. Minus 0.24 n. Okay, sorry. So okay, for now we come with this fy, summation of fy. What you have is n equal to w, which is 1,500 times 9.81, which is the gravitational acceleration, and then what we get is 14,715 Newton. Okay, and then we can sub this normal force into this equation. So let's sub this. Two, 14,715. Okay, so the answer that we get is 10.35 meter per second square. Okay, now we come to this first. So what is a moment, the formula of moment here? What is it used for actually? So actually it's used to determine whether the car is slip or not, because in this condition we have to prove that this car, whether it's slip, S-L-I-P, whether it is slip or not. Okay, if this distance is lower than 2.5, so it means this car is slipping, and then is slipping. So and then for if the x is larger than 2.5, which means the car is not slipping. Okay, so now let's do this. So we got 3 meters here. Okay, sorry about that. The length is quite a big difference, but it's the same. So here is the 3 meter. Okay, so we got an n here times the x plus, okay, plus the f times 3, sorry, times 3 equal to force, the driving force, times 3. Yeah, because the distance, yeah. So, and then let's start all the value in this equation. Equal 2003. Okay, so now we can get the answer. X is equal to 3.16 meter. So as I said just now, if the x bigger than 2.5, which means the car, it is not slipping. And then if this x is lower than 2.5, which means it is slipping. Oh, sorry about this. So what we calculate is x is equal to 3.16, which is larger than 2.5. So this car, it is not slipping. Okay, so yeah, here is the calculation, and thank you very much.